One sentence can tell you a fact. A paragraph can tell you a story. But a million documents? That can tell you the opinion of an entire civilization. Every day, companies process millions of customer reviews. Governments scan thousands of intelligence reports. Researchers navigate oceans of scientific papers. The problem? No human can read them all. Document-level NLP is how machines understand not just sentences, but entire collections of human thought. In this video, you'll watch documents organize themselves by topic, reveal their hidden sentiment, and declare their stance, all automatically. Before deep learning, understanding documents meant keyword matching, counting words and hoping for the best. Then statistical topic models like LDA discovered hidden themes. Neural classifiers learned to categorize with superhuman accuracy. And now, large language models can analyze sentiment nuances that humans miss. Today's Document NLP Toolbox has 4 core capabilities. Topic modeling discovers what documents are about. Text classification puts them in categories. Sentiment analysis reveals how people feel. And stance detection uncovers where they stand on issues. Let's examine each one. Topic modeling answers the question, what is this collection about? The most famous algorithm is LDA, latent Dirichlet allocation. Here's the key insight. LDA assumes every document is a mixture of topics, and every topic is a distribution over words. This document might be 60% technology, 30% business, 10% politics. The technology topic contains words like algorithm, neural, compute. The business topic, revenue, market growth. LDA works backwards. Given the words you see, it infers the hidden topics that generated them. Watch as documents organize themselves. These cluster together because they share the technology topic. These form the finance cluster. Overlapping clusters mean documents discussing multiple themes. But LDA has a weakness. It's a bag-of-words model. It ignores word order. Dog bites man and man bites dog look identical to LDA. Modern neural topic models like BERTopic fix this by using transformer embeddings, capturing meaning, not just word counts. The result is dramatically better topic separation. Text classification is the workhorse of NLP. Spam or not spam, positive or negative, news, sports, politics, or entertainment. The modern approach: take a pre-trained transformer, add a classification head, and fine-tune on your labels. Input text flows through the encoder. Every token attends to every other token, capturing context. The CLS token aggregates the entire document into one vector. That vector feeds into a neural classifier that outputs probabilities across categories. But documents often belong to multiple categories. A news article about AI regulations in healthcare is simultaneously technology, politics, and health. Multi-label classification handles this, assigning multiple labels with independent probability scores. How do we know it's working? The confusion matrix reveals everything. Diagonal means correct. Off-diagonal reveals systematic errors. Maybe your model keeps confusing technology and science. These patterns guide model improvement. Sentiment analysis goes beyond positive and negative. Modern systems detect fine-grained emotion, anger, joy, surprise, disgust, and aspect-level sentiment. A phone review might say amazing camera, but terrible battery life. The camera aspect is positive. The battery is negative. One document, multiple sentiments. Stance detection is sentiment's sophisticated cousin. Given a claim like AI will replace most jobs, does this document favor it, oppose it, or remain neutral? Stance detection powers fact-checking pipelines, political analysis, and social media monitoring. It's how machines understand not just what people say, but where they stand. Put it all together. A document enters the pipeline, and in milliseconds, its topics are discovered, its category is assigned, its sentiment is parsed, its stance is extracted. Structured insight from unstructured text. But here's the twist that keeps researchers awake at night. Read this review. Oh great, another phone that dies in 2 hours. Just what I needed. The model says positive. Confidence, 92%. It's completely wrong. This is sarcasm, and sarcasm breaks everything. The words are positive. The meaning is devastatingly negative. Machines can't hear tone of voice. They can't see the eye roll. And it gets worse. A model trained on movie reviews performs beautifully, 94% accuracy. Deploy it on medical text? 51%. Barely better than random. Domain shift is the silent killer. Every document model carries hidden assumptions about what text looks like. Change the domain. Those assumptions shatter. One changed word can flip an entire classification. Great film versus great failure. Same structure. Opposite meaning. Document models are powerful, but they are fragile. The modern document NLP stack is a 4-layer architecture. Pre-trained embeddings capture language knowledge. Fine-tuned classifiers adapt to specific tasks. Multitask models handle multiple objectives simultaneously. And at the top, LLM-powered pipelines can analyze documents with human-like understanding. The applications are everywhere. Customer support systems classify millions of tickets daily. Healthcare platforms analyze clinical notes for adverse events. Legal tech reviews thousands of contracts in hours. Social media platforms moderate billions of posts. 3.5 billion emails are classified every single day. But remember, every model is a lens. It reveals what it was trained to see and hides everything else. Sarcasm, domain shift, adversarial fragility. These aren't bugs. They're fundamental limits of how machines understand human expression. Coming up in Unit 3, few-shot and zero-shot learning. Performing NLP tasks with almost no training data. Advanced prompting techniques, controlling language models through instruction design. And model optimization, making these systems fast enough for real-time deployment. Subscribe so you don't miss a single breakthrough. From sentences to documents to entire knowledge collections, that's the journey. Let's keep going.